Back to the exercise. I'm not sure. Wait a second. Okay, back to the exercise. I think that's where we were. Something is not correct here. Wait a second. All right. So after studying, how do you move to create a horizontal line? So this is a positive slope, which means you have to start, if you have a distance versus time, you'd have this type of graphic. So you have to leave the origin and move away from the origin with a positive and consistent step. Now in this graphic, you have velocity versus time, and you have a positive slope. The positive slope of velocity versus time graphic is an acceleration. So in this case, you are speeding up. Like you start with zero speed and the speed keeps growing. So you are speeding up. You have a constant acceleration. How do you move to create this type of graphic? Well, just start moving and speed up basically. I mean, we can do that up to, let's say, 5 meters per second if you are in good shape. 4 meters per second. In my case, probably 2 or 3 meters per second. But we get to a point we have to either keep the speed or slow down. So these sprinters, that's how they do. They put maximum acceleration, or they put acceleration in the very first few seconds of their run, and they reach some maximum speed, and then they try to keep that one. So in this case, look at this, the velocity is always positive, is always above zero, right? But the velocity is diminishing every single time, which means the speed is diminishing. So it's a case that in a graphic distance versus time, the velocity is diminishing, which means the slope is um, um, the slope is so you start with a maximum velocity and the velocity diminishes to zero, which means you have a constant acceleration in this case, but the acceleration is negative, which means you are moving in the positive direction, but your velocity keeps diminishing, right? So something like this. So the velocity here is bigger than it is here. The slope is diminishing, and eventually the velocity is zero when you curve like that, right? When you have a df, a d dt, at this point the velocity is zero, right? D for displacement, d dt is equal to zero at this maximum point. So stop. That was a bad explanation, but I hope you got. If you don't, email me. Now, where are we? How do you move to create a straight line velocity graphic that slopes up? So here, this slope of velocity versus time is a positive slope. So the velocity is negative in the beginning, and the velocity goes zero. So the acceleration is more than zero. Your velocity is equal, always less than zero. So what's the situation? So the situation here is you are the acceleration has a positive sign, so you are moving towards the origin. So you're running towards the origin, but you are slowing down, basically. So when you have the sign of velocity and acceleration opposing each other, then you have a slowing down situation. When the two signs are the same, so velocity and has a sign that is different from acceleration, so sine different from acceleration, then you have a slowing down process. Slowing down process. But when you have velocity and acceleration with the same sign, you have a speeding up process. Speeding up. Okay. So how do you move to create a straight line? Okay, we did. So in this case, the velocity time graphic of an object, blah, blah, blah. So the velocity is 0, and then the velocity now is at 2 meters per second, and then the velocity is 2 meters is 0 again. Total distance traveled by the object. So here, basically, so the point you know, right? So velocity is dx dt, right? So don't tell the students this type of things because they don't know. So which means dx, velocity is dx dt. So if you have a graphic velocity versus time, if you integrate, that's easy for you to know. If you integrate your velocity versus time curve, you have the total distance traveled, basically. So if you calculate the area and this curve, you would know the total distance traveled. So you have, so what's the total area here? 6 minus 2 is 4. So 6 minus 2 is equal 4 seconds, right? And you have a height, which is 2 meters per second. So when you multiply those two, you have the area under the curve that gives you the distance, which is 4 seconds times 2 meters per second. That is 8 meters. Okay. Both the velocity graphic. I think I will have this done up to here. I think this is enough. I have to stop anyways. So I will tell the students up to 6, right? Up to 6. I think that's gonna be enough for them. They still have homework to do. Okay, that's it. But if you wanna work on the rest, in case somebody asks, you can do that. Thank you.